will be giving you the different symbols of industrial motor control. The most common symbols used in industrial control. But as we go along, we will be encountering more symbols. Okay? Now, knowing the symbols are very essential for industrial motor control tender, the operator. Because when it comes to wiring installation, motor installation, or control installation, then of course you have to follow a diagram or schematic diagram. And then if you do not know the meaning of the particular symbols, then of course you cannot interpret the diagrams. Then it is very difficult for you to do the connections. That is why this morning I will give you the basic one, and then when I give the symbol, I will immediately let you see the actual appearance of that particular part of the contactor. Now, we have here this one is a normally open contact. Okay, normally open contact. So normally open contact. That one. Then the other one we have here the normally closed contact. And then when it comes to heater, or that is part of the overload heater, we have here the symbol. That one. This is actually heater, no? Overload heater. We will make it like this. Overload heater. Okay. But if you will look at some other books, instead of using this one, they are using this symbol. Like this. Like that. They are using that. No? That is the old symbol. But this time, we are going to use this. Okay? Then, for the push button, like for instance this one, push button. Now this is, anyway, I'm going to introduce to you the different parts used in motor controls, and at the same time, different types. Because, for instance, this one, this is a push button. This is what we call brake make push button. Then I'm going to explain to you why it is called brake make push button. And then this type is what we call flash type, because there is also what we call an open type there. No? This is the flash type. Now, for the push button, we have this. That one. This is the normally open push button. Now remember, this is momentary. Momentary. Meaning, when you press the button, this one will contact here. But as soon as you release your finger from the button, it will go back to normal position, because this is spring operated. Okay? So this is what we call normally open. By the way, when we say normally open, normally closed, that is not being used yet. So if you are going to use, then pressing the push button normally open, that will become closed. As well as the normally closed, when you press the button, that will become open. Okay? So when you say normally open, normally closed, it is not being used yet. Then we have also another one here, a push button. That one. That is a normally closed push button. The same. there is a spring tension here, like that. So when you press the button, the contact here will move down, then there is no complete path of current. So that is normally close button. Now, we have also here, I'm going also to give you the symbol of electric timers, no? And then we have also knife switch, like that. But I'm only give you this one because these are very common. And then we have also another one here. So if you like that, no? This is a circuit breaker. Okay? Circuit breaker. So instead of using a safety switch, having the fuse, we will be using a circuit breaker. And of course, I will explain to you also a circuit breaker. Circuit breaker is a non-fuse. So non-fuse switch. So when there is a short circuit, this will only trip. Then you reset by holding the holder, then pull it down, then it is reset, then switch on again, then that will function. So this is the circuit breaker. Now I'm explaining this to you because these are the common one. Okay? Then we have another one, no? This is also very important. We have this. So this is what we call a magnetic coil. Magnetic coil. No, I use this one. Actually, a magnetic coil is like this. But to make it sure, I will be using this. There are also books. Instead of using this one, they are using this one. This is also a symbol of magnetic coil, meaning a solenoid. Okay, solenoid na siya. A coil of wire. So that's the symbol. So these are the common symbols used in industrial control. Because I will immediately introduce to you, right after having all this, I will introduce to you the symbols, no? I mean, the actual definition or diagrams in a magnetic starter. Okay? So these are the common one. Now, let us have another one. I will show you because I have a book. I think I sent already, no, particularly in my master students, I already sent some picture there, some diagrams. So just keep it. I give you that in advance. Just keep it because I will use that during our lecture. Now, I am not fan of giving immediately the diagram without explaining it. But I give you that in advance, okay? So that you will also read. Then, of course, you will not ask a question there. But there are already questions in your mind. Then, that will be asked using your messenger. Okay? Now, I have here the magnetic contactor. Remember, magnetic contactor has different brand and different sizes. Okay? This one, no? This contactor is can be used for 220. This, the holding coil here, instead of calling magnetic coil, we call it also holding coil. So the holding coil here is rated 220, no? But this one can be used for 440, 550 volts. Now, considering that the holding coil or the magnetic coil here is 220, then I said this can also be used for 440, 550, meaning the contacts are capable, no? Capable for 220, 440, and 550. Now, the holding coil is 220. Then if you will ask me, sir, how about if the power voltage, or rather the line voltage for 40, and then you have only 220, then the motor is rated 440. So, of course, the power is 440, but the control circuit of your starter is only 220, then we will be using a control transformer. So again, I will explain that. So you have here, no? You have here the contactor. Now, remember, this contactor is still good. No, it's still good. This one here, you have here the normally open. In every contactor, you listen this, no? In every contactor, there are always 3 main contacts. Okay? So you have here 1, this is a pair, 2, this is also a pair, then 3. You don't need to worry the appearance of this contact because I will dismantle this or disassemble, and then I will let you see the actual contact of main. So you have your 3 main contacts. But this particular contactor, considering that this is also a very big contactor, no, used for motor that having big horsepower, then you have here the standard marking for this brand. Okay? So these sides here are your what we call auxiliary contacts. So you have here the main contacts, you have here the auxiliary contacts, side. So if we have normally open here, we have also normally open here. If we have normally close here, we have also normally close here. So opposite sila. No? Then this type of contactors, okay, you will have 2 normally closed and 2 normally open contacts, auxiliary. You have 3 main contacts that are open, can normally open. And then you might also ask me where are the terminals for holding coil, because this will not energize like this if you will not energize this or put that in at 220 volts. So you have here the terminal of your holding or magnetic coil. Okay? So you have here the symbol. You know, it is very easy for you to locate the main contacts because of numbers, terminal numbers. So for instance, this is your normally open main contacts. The symbol will be like this, like that. Okay, now remember, no main contacts that are normally closed. So when we say normally closed, all are auxiliary contacts. But there are also open contacts that are auxiliary, considered auxiliary contacts. So these are the main contacts. So how would you determine if that, now remember this is, the symbol is open contact, right? Open contact. Normally open contacts. But how would you identify if this is a main contact or an auxiliary contacts? Because the normally open contacts for main, the same symbol used in normally open for auxiliary contacts. So you have here, you can identify main contacts because of this terminal mark. 1, 2, 3, 4, 5, then 6. Meaning to say, when we see 1 and 2, then that is one main contact. We have also another main contact. This is another contact. Okay? Now, at this side, we have also, let us see, you have 2 normally open and 2 normally closed contacts. So you have here normally open contact. This is auxiliary. In the other side here, this is your normally closed contact. Then we have also here the normally open contact. Then we have also here the normally closed contact. Then how would you identify the main contacts from the auxiliary contacts? Again, there are terminal mark or numbers. So here, which is very common, 13, 14. Then the other one here, no, will be 31, then 32. Okay? Here, the normally closed first is 21, 22. And then here will be 41, 42. So far, that are the terminal marks. So if you will identify where is the terminal 1 and terminal 2, very easy for you to identify. Why? Because you have the different contacts. So maybe this one is being placed here, this one is being placed here. It depends. So what you are going to remember are the numbers. So if that is 13, 14, this is the most common. Particularly if the contactor is only having one auxiliary contact, then that is normally open. Okay? So that are the symbols. And in the push buttons, because you will be using normally open, normally close push button for on or start, on or off, or sometimes we call it stop and start. So if that is a combination of on and off, then this is the symbol of your push button. Okay? You have here the symbol of your push button, that is here. This is your off button. Then you have your, or we will have it like this. This is your normally open, then that is an on button, and then you have your normally close. Okay, so this is your consider this is on or start. Okay, and this one is off or stop. Okay, remember the normally open contact, it is always start button. Then the stop is always normally close. But these are momentary button. So when you see momentary button, you press that for a short period of time. As soon as you release your finger, as what I have told you a while ago, this will go back to normal position. That is why it is called momentary push button. Okay? Momentary push button. So these are the following. Now, and then for the overload relay, we have here. In the overload relay, you have 3 heaters. You don't need to worry because I will explain this, no? The principle. So this is the heater. Now remember, it is really necessary to control the motor, not only using a magnetic contactor, but a motor should be protected. That is why we have an overload protection. So the part that we are using there is, of course, the overload relay. Okay? So when there is an occurrence of overload in your circuit, automatically, the push button is off. And that is because of your overload relay. So I will also explain to you the principle. Why is it will open when there is an overload that might occur during the operation of the circuit. Okay? So you have your heater. These are heaters. And this is found in your overload relay. This contact is found in your overload, push buttons, and this one are found in your main contacts. Again, in a magnetic contactors, we have 3 essential parts. You have the magnetic contactor, you have the overload relay, and then you have the push button. Then we call this one magnetic across the line starter or direct online starter. Now, I will also explain to you why is it is called direct online, why is it is called magnetic across the line. Now, there are 2 classes of magnetic starter. We have the full voltage and we have also the reduced voltage. So, if you will be using a full voltage magnetic starter, meaning to say, when we say full voltage, if the rated voltage is 220, then of course your motor is also 220. When you switch on the push button to control the operation of the motor starts and automatically it will receive a full voltage of 220. But this is only intended for motors having small horsepower. There is a certain maximum horsepower for a single phase motor. If that will go beyond the maximum, then this time we will be using a large horsepower motor. Okay? And then you will no longer use the full voltage magnetic starter, but instead you will use the reduced voltage magnetic starter. You know why? Because during starting, according to the book, during starting, when you press the push button, even without the load, no, remember the motor is a prime mover, you will run the motor without a load. The circuit will draw 3 to 5 times of the current. So if you don't have overload, no, and then it will reach to more than its capacity, more than the amperage of the particular motor, then the motor will trip because of the overload protection. So we will see to it that the overload relay that we are using is really intended for that particular motor, because every motor has its what we call the full load current. So for instance, sample, you have this kind of horsepower, and then this horsepower is only good for 5 amperes. That is the full load current of the motor. Then you have to put a load that is not more than 5 amperes. If that will go beyond 5 amperes, then it is now the job of the overload relay to trip. Why? Because if this will not be cut off, then there's a tendency that the wires or the windings of your motor becomes hot. No? If there is no protection, a tendency that the winding will burn. Okay? So in order to protect the windings of your motor, then there is a need for you to have the overload relay. So when the overload relay will trip, then shut down. The motor will automatically stops because the power is off. That is from the circuit, from the magnetic contactor. But the circuit breaker is still on. So I'm going to explain to you the schematic diagram this later on. No? As we start our lesson about magnetic across the line starter or direct online starter. When I discuss that one, then you will thoroughly understand the principle of magnetic starter. So that are the basic symbols that I am using. Now as you see, I have here different parts of a magnetic starter. No, but I'm going to introduce to you this as I display all the types or all the parts or different parts of motor controls that are available in our laboratory shop. So I brought some of these in my home just to let you see the sum of the parts of motor controls. Okay? Now remember, parts of motor controls are expensive. The one that I introduced, this one, no? If I'm not wrong, this will be like 3,000. It depends on the horsepower. 3,000 for this alone. That is very expensive. But it will also depend on the brand. Now this is Kasuga, made in Japan. So very expensive because there are different brands. Now I will also introduce you the different brand. For instance, this one. This is another brand, no? But it's still Japan. Made in Japan, another brand. So if you have the same horsepower, you have another brand here, you have another brand here, then you have the same horsepower. The power is the same, the current is the same, but the price is different. Okay? So depende sa brand. You have the US, you have the European, and then, of course, we have also a locally made magnetic contactors because we have already our own manufacturer in magnetic contactor. Then, of course, people, particularly the agent, no? Well, when you go to electrical supply or supplier or store, they will always recommend to you the expensive one. But of course, when they introduce the expensive one, that is very reliable. But of course, as an end user, particularly our budget is not so good. So no, so you don't have enough budget, then we will be using a similar parts with different brand. Then that is very cheap. But for me, if you will really use the contactor, it depends on what is the brand, regardless of what is the brand, provided you are using all the standard way of using it, standard way of installing it, it will take long. It will take long. Even how good is your part, but if you do not know how to apply the standard way of doing it or installing it, then of course it will not take long. That is why we need to know some preventive measures in connecting all these parts. You don't need to worry because this will be explained to you thoroughly, and you can understand it more, especially if we will do that in actual. But considering of this pandemic, we cannot do that. We will just wait. No? Anyway, maybe after December, though we are already done. Let us say, you are not doing the actual. We are more on lecture because I will demonstrate on how to connect it. No, I will really have the circuit breaker, the magnetic contactor, the overload relay, and the motor. And I will really press, then you will see the motor is running. That's the actual. Supposedly, that is the one that you will connect when we have our laboratory activities. But we cannot do that this time. But if there is a chance, then I will let you connect. You don't need to worry about these materials. We have plenty. We have plenty magnetic contactors, overload relay, and post buttons. Okay? I can give you all these parts, and then you can connect that individually. So that is, an advantage of having these instructional materials. If I am not mistaken, I hope I am wrong, there are universities, there are colleges that are offering the same course, no? Particularly electrical engineering. And then ours is electrical technology. Then we are offering this subject. In engineering, there are also control devices. And in technology, there are also control devices. I'm not trying to say that they don't have this, no? But as to the volume of the materials, I think we will not be behind. We have that here. We have it here in USTP. That is why if the admin or the administration cannot immediately provide all the materials that we need, it is now the initiative of the instructor how to secure all these materials. So what we did, we use our influence. We have so many students now working in industrial plants, and then they are already in the position. So of course, we just simply talk to them, including the managers, including the supervisor of that particular plant, and then we explain to them our needs. And then of course, time to time, they keep on maintaining, in order they really apply the preventive maintenance. If they found out that there is a need to replace this particular part, though that can still be used, they will immediately replace it with new one. That is part of preventive maintenance. So those we consider that surplus, but it is still good, or maybe there is something, shall we say, a little defect. Now remember, there are 3 main contacts. Okay, if you have a 3-phase motor, and then one of the main contacts is defective, we can still use the 2 contacts. We just simply bypass the other one. The motor 3-phase is still controlled by using that particular contactor. But to be safe, of course, we will not use that. But for emergency cases, we cannot find any means. Then as a technician, as an electrician, we have so many options, alternatives, on how to run that motor again using that defective one. Okay? While not securing yet the new one. So we can still use it. Okay? So that is part of troubleshooting and repair. Now, so those are the different parts of electric motors, and then the symbol that we will be using. Then the next video, I'm going to introduce to you most of the parts used in industrial control. That includes already relays, control relays, timers, limit switches, and then some other mga emergency buttons, selector switch, emergency switch. I'm going to introduce that one because we have that in our laboratory shop. Okay, so watch out for the next video. And then, of course, for me, I'm not going to write all the names of every part. I will just simply let you see it. For instance, like this, no? If I will say, this is a selector switch. Okay? And then this one can be used as on and off. But you can also use this for, if your circuit is can become automatic, you place it there. Then the circuit is automatic. If you will look press the button again, then that is for mechanical. So this is a selector switch, but can be used also as an on and off. So it depends. It depends. Now, for instance, we have also another one here. This is a push button. Off push button. If that is red, off. If that is black or green, that is on or start. Okay? So you will be, I will introduce all these things. You know, what is the advantage of knowing the principle, the different principle of every part? It is very easy for you to troubleshoot and repair because you know the principle of operation. At the same time, it is very easy for you to design circuits, the control circuits. There are two circuits used in magnetic starter, the power circuit and the control circuit. And of the two circuits, the complicated one is the control circuit. Okay? So that's all for this video. And then watch for other video because I will again introduce all, if possible, if that is available, I will introduce to you the different parts of magnetic starter.